Okay, welcome to the second half, the first class. This microphone keeps going in and out. That's what happened. Right. So, again, this class is about learning how to become a lifelong learner, picking on emerging technologies as object of your learning. Okay. Having said that, we can focus on a whole bunch of topics that that are of interest, that may be of interest to you, and this is something that you can, I guess, cling on as your term project focus. We can focus on two sides of things. I'm just giving an example. We can focus on the driver itself, or we can focus on things that are driven by emerging technologies. Okay, what do I mean by that? We talk about different areas of emerging technologies. You know, we usually give something like nanotechnology or quantum computing as an example. Those would be an example of the driver. So it's the emerging technology itself that's going to be driving a whole bunch of cascade innovation down the line. Okay. On the other hand, we can sort of like focus on the problem area. Sort of like what is the issue? What are the global challenges out there that are likely going to have solution adapted from this new basket of emerging technology? So I just put it down here as focusing on the driver versus focusing on the driven. Okay. And you can, you know, for example, again, obviously, if you focus on the driver, you can say, okay, what's happening in nanoscience and engineering? Okay, how soon is it close to be able to operationalize certain things, or how much of a control, how much of a scale, how much of a stability, and all kind of stuff. So let's dig into let's start with well, we can say start with a Google search on nanoscience and technology and dig down from there. Okay, so those be focusing on the driver. Again, genetic science and engineering, that will be the main driver, right? That's driving all kind of innovation and technology about anything from the COVID vaccine. This is all not doable without genetic science, right? Then you can focus on what's happening in mathematics itself. Okay, when I say mathematical science here, I include also things like algorithm and so forth. So what's happening? And of course, one of the poster child of what people got excited about would be things like cryptography and, you know, algorithmics, things about inventing algorithm to do this and that. And in this class, I might give example of algorithm that does quantum computing, or algorithm that does encryption, or and so forth, right? Public key encryption and so forth. We'll have example of that. So they would be focusing on what's happening in the mathematicians community, so to speak, or computer theorists community. What are they coming up with? What are they working on? What are they trying to develop? Okay, and then you can focus on, I guess, I for lack of a better word, I call it intelligent science and engineering. This would be the whole umbrella that, okay, of course, includes things like AI, but also includes things like natural intelligence. You know, like bee has its own beehives, has its own swarm intelligence behavior. Nature has its own ability to organize into optimized solution, things like that. So this is about how do we come up with intelligent solution or intelligent behavior or ability to communicate or intelligence. So, you know, things obviously artificial general intelligence is a very big thing now. Okay, that would be the poster child of this topic. But again, emergent intelligence, again, you guys know about how, let's say a fish, not fish, but a school of fish in the ocean, right? Or a flock of birds, they swim intelligently by design, you know, turn left, turn right, evading predator and so forth. But if you could ask individual fish or individual birds, are you making on this decision? No, it's not. Okay, the fish and the bird is making very simplistic algorithmic rules, something like if most of the people turn right, you turn right. If somebody comes dead ahead, you turn left, or something like that. Very basic, simplistic rule. But when you implement as a system, it emerges into what's called emergence intelligence. So that's also a very, very interesting topic to look at. Okay, and incidentally, things like cellular automata used to be a big topic of research in that kind of spirit, although not necessarily the same name of a research area. But cellular automata is more like one of those. When you see a grid of those computer games like Tetris, right? But instead of having blocks, you just have each cell following certain thing. Like if the cell to my right turns black, I turn black. If the cell to the left turn white, I turn black, or something like that. And then you start with initial condition and see what happened with the whole grids. And then you evolve this kind of very intelligent behavior that was not designed. So things like emergence intelligence or artificial general intelligence, this is a very active area of research. These are some things going to be driving, okay? So themselves, they are the emerging technologies. And they're going to be driving a whole bunch of other emerging technologies, right? So you can think of technology as a hierarchy, so to speak, right? So computing is technology, right? But computational genomics is also a technology, but that is made possible only because we have computer. Computer is only made possible because we have mathematics or whatever. Okay, so it's not just a whole bunch of separate emergent technologies. Some emergent technologies are the mother, so to speak, of other emergent technologies. And quantum science and engineering, okay, of course, quantum computing is a big thing. But I just want to make a point here that quantum computer, you probably hear things like quantum computer is going to crack code, but quantum computing was not, so to speak, invented to crack any encryption codes. The original desire or original wish for quantum computing was simply this. Richard Feynman, physicist, he kind of realizes that we were using computer to study physical system. But physical system at a macro level, right, behave with mechanical laws, differential equations. So computers were very good at doing that sort of thing. But when we try to study physical properties or physical phenomena at the quantum scale, there's no macro analog. So to get the computer to study physics, instead of trying to find the macro level analog of quantum properties so that regular computer can study, he thought, well, why don't we just make the tools themselves go down to the same level as the subject? If the subject is quantum mechanics, then the computer that studies it should be somehow made of the same stuff, quantum properties. So quantum computing was about trying to get computer to study quantum phenomena, not trying to crack RSA code or anything like that. Okay. Anyway, we'll talk about it later when we come to that lecture. And this is just focusing on the sort of like hot topic right now, right? But like I said, if you go back to things like here, husbandry, material science, industry, all kind of stuff, there's still emerging technology in those topics. Okay, material science, precision farming, like I said, being a good example. But here I'm just listing the sort of like the new wave kind of thing, so to speak. Now that would be focusing on the driver. Focusing on the driven means that there are problems that you think so important, and yet the reason they're not solved right now is maybe because we don't have the technology to solve it. So we kind of like speculating right now. We say there's some problems that are complicated or not solvable. Okay, maybe some of it is just political will. If you solve political will, you can solve that problem. Maybe environment is one of those things. Okay, but if we can't rely on politician or political will of the society to solve environmental problem, maybe we can hope that emerging technologies from science and technology can help with that. Okay, it's a little bit pessimistic but actually that's probably true. I really believe that we have absolutely all the technology we need to solve global warming right now, if we just willing to pay for it. Okay, we don't. The scientists can just use the textbook they have right now. They don't have to do a lot more research. Well, they have to do implementation research, obviously, but the science is there. Okay, that's not. It's not for lack of science that we haven't solved the global warming problem. It's lack of political will. But having said that, okay, let's say we don't have the political will, right? We're gonna have to do carbon sequestration. That's when we say, okay, carbon sequestration is an emerging technology that is yet to arrive. Okay, so then we can study that, we can see that. Okay, same thing with maybe plastic recycling, reuse, and so forth, right? If you have the political will and individual have personal responsibility and discipline to recycle, be fine. But if not, maybe science can come up with solutions like biodegradable plastics. Okay, now we would need those if we have the political will and individual discipline, but unfortunately we can't rely on that. So this would be not saying that we need emerging technology to solve this problem. We don't technically need them a lot of times, but until we get our act together, we'll probably have to rely on scientists. Okay, so this will be those areas. Okay, so climate change, global sustainability, and so forth. You have to look at the carbon sequestration. That's a big thing, right? That's not about reducing our generation of carbon particulates, but actually sequester or absorb the carbon that's in the atmosphere into the ground. Now that process, by the way, is going on every day already by the ocean, by the plankton and whatnot. The point is that there's a lot of carbon generated. There's a lot of carbon being absorbed on the daily cycle. But the balance, you talk about like huge number on the left, huge number on the right, and they are in good balance. The point is we came in and just by our action, we tip the balance the wrong way. Okay, so we're not talking about carbon sequestration on the scale that the planet is already doing. No, we're just talking about carbon sequestration on the scale of the carbon that we extracted from shales, from the fossil fuel generated and released into the air. Okay, same with sustainable agriculture. Okay, over here, there's enough room in this earth for triple the population, but we need the agriculture to be sustainable for that. Okay, precision farming, circular nutrients, bee technology, all kind of stuff. Okay, so these are looking at a problem. Renewable solar energy, right? Wind, solar farm. We talk about this is the generation thing, and the second part is the storage, creating the battery. Again, this is about. Remember, I told you that you have the wind can drive the sail can drive the boat. Okay, but that's not storing. You're not storing the wind anywhere. But if you take the coal, that's already in storage. You burn it, you generate steam, drives the ship. Fine. Now, how about putting them together? You have wind, which is happening right now, but then turn that into something we can store when it's windy, use it when it's not windy, and that's where battery technology also comes from. By the way, battery technology does not have to be chemical, always, okay? For example, you can, let's say when the sun is hot, use it to heat a lot of sand, right? And keep that sand in an enclosure, like a hut or something, right? And the heat extract from that at night can be used to drive the turbine. So, so battery technology is about conversion of energy in one form into another, kinetic into potential and so forth. Tidal turbine is a big thing that's interesting. Waste management, we talk about that, biodegradable circular economy platform again. Well, this one may rely more on political will than this one. This one rely more on scientists. I will be using biodegradable plastic as one of the examples, okay, of how we can learn about this. Let's say Okay, so these are about, global climate change, global sustainability, and then we talk about things like, molecular biology. Again, this big thing about genomics, transcriptomics, proteomics. The genomics is about the library. Okay, the library of what is expressible. What gets expressible is falls under the rubric of epigenetics. Okay, and that would be something like transcriptomics. That means what kind of gene get transcribed. So it's a bit like gene is not the recipe being used to generate life. It's a recipe that can be used to generate life. Whether or not that recipe gets picked up to generate life, that has to go through a process of gene expression. Okay, so how gene get expressed, how do you regulate that gene expression, all that's very important. And because most of the biological mechanism at the molecular scale happens through the agency of protein. Okay, so this collection of what protein to construct, how do proteins work together, when to regulate the production of protein and so forth, that proteomics, all that's a very big thing. So these are the area that themselves, okay, would be the hub of emerging technologies. And once the challenge in this area, say some key problem in proteomics are solved, then you can use it to solve to become a driver of other technologies like medicine, okay, like targeted therapy in oncology, in cancer treatment. I'm running out of voice, or not today. Material science, again, nanoscale, right? Additive manufacturing, this is not necessarily nanoscale. In fact, most of it is not. So, 3D printing, right? That's using with something that's quite malleable with plastic. But you can certainly do a 3D printing with concrete, okay? So that sort of thing, or you can do kind of laser etching, you have something that, well, anyway, emerging out of the solution, and you shoot laser at it, and then it chisels out little pieces and so forth. Biomechanical cybernetics, that's a big thing. That's, we've actually been cybernetics or cyborg ever since we human beings invented eyeglasses, I think. Okay, the minute we wore shoes, I think. The minute we wore shoes and wore eyeglasses, we were already cyborg in my thinking. So robotics, IoT, that's a big thing, right? Autonomous vehicles. We think of autonomous vehicle as a big thing because we're familiar with car and the wish for self-driving car, but certainly autonomous logistics is a bigger thing. It's the planning of the whole sequence of industrialized delivery, supply chain, and all that stuff. Underwater and space robotics is a big thing. Drones, swarms. These are all different areas that you will say, oh, there's a problem in here that we can work on. Biomimetics, that's my favorite thing to talk about. This is where you you mimic nature because nature is no slouch. Through billions of years of evolution, it probably came up with a very good solution. Okay, how do you stick 20-ounce animals on the ceiling without glue, right? So that involves some kind of nano structure of the feet of the gecko, right? So you can't invent it. Well, you might as well take a live gecko and sort of like put it under the microscope and see what does the 3D imprint looks like, and see if you can mimic that, right? Or sharp scale, for example, maybe it has some certain hydrodynamics property that makes ship go faster. I don't know. Okay, so this is about taking nature's homework and see if we can mimic it. Okay, a lot of time we can, a lot of time we can't, a lot of time we get inspired. But this is I think a lot of time when we talk about being inspired by nature, we don't always have to stick to the final form. Think about it. An airplane is inspired by birds, but it certainly doesn't fly the same way as birds do. In fact, it would be very hard to create a mechanical airplane that flaps the wing, like the birds. On a smaller scale, it would be better to do what the hummingbird does, for example. That's when you have these drones that sort of like gains a lift on both forward stroke and backstroke, like the bees. Some birds are like bees. So you can look at that and say, hey, maybe we can design a small drone for that, but we certainly can't make a passenger jet from it, flapping the wings, you know. So mimicry is not the end game, okay, but it opens up the possibilities, okay. Soft robotics is one of those. Soft robotics is a big area. I really wish soft robotics is on the top of Basai students' mind. Why? Because it's a good combination of everything we talk about. We talk about technology, we talk about digital platform, right? Applied digital intelligence, but we also talk about health system, health delivery, okay? And a lot of health delivery or even a medical application, you can't deal with industrial robotics. You know, this big metal arm that grabs stuff and uses suction to stick things and so forth. You have to use things with soft, locomotion is soft, touching is soft, feedback is soft, maybe a bit of haptic system, that's, you know, feedback. So soft robotic is a very, you know, I really wish a lot more Basai students are looking into soft robotics. And then of course, you know, things like neural human man-machine interface, we hear about Neuralink, okay? But human-machine interface doesn't always have to happen at the neural level all the time. You know, I now wear mechanical watch and I also have electronic watch because this thing takes the sweat from my arms and then measure the sugar level, not accurately, but you know, it's beginning to get there, right? At night, you can stick your finger into this little ring that measures your oxygen level throughout your sleep cycle. So this kind of man-machine interface is going to be big. It's going to be big, okay? And I would imagine in 50 years' time, there's going to be a better way for us to talk to our mobile phone than to do this. You know, it just looks bad. I just, you know, if aliens were to come to see us, I would wish that they came before mobile phone, or they came way after mobile phone. Because if they come and see us doing this, they're not going to be that impressed. We're going to look ridiculous. Okay, so in the future, there's going to be a way that we can get engaged with our mobile phone without doing this to our face all the time. It looks a little bit retarded. Okay, so we have to look better as a humanity to show off to the aliens. So man-machine interface will come to that. Okay, so something maybe through some kind of we'll talk about Google Glasses and all that. We'll see. Okay, may not be something that's local here. Maybe something that's projected out in the augmented reality. I don't know. Okay. And of course, my big area. This is, you know, where I live. Basically, this is in the area of data science and machine learning. Of course, we have this natural language processing. This chatbot is a big thing, right? We'll be using that a lot. And then on the image side, image recognition, image processing, generation. I can ask DALL-E to generate a picture, and it's very clever, and it's creating very coherent picture. And you have to ask, how is it doing that? Well, the way it does, I'll just give you an intuition. If you can get something that looks coherent, real picture, okay, and transform it into something that looks completely random, and do it in such a way that you can reverse the process. You can imagine that the reverse process is able to create something coherent out of something that looks random. And that's where the generation part comes in. Anyway, so we'll talk about that. This area, which is big to me, I've done a lot of, not a lot, I've done some research on this, which is instead of learning about input, output, or unsupervised learning or supervised learning, I learned the graph structure, relationship between things. So graph learning is going to be a big thing. There's a very simple version of it is graph analytics that you may be familiar with, would be like social network analysis. Okay, this is something that I'm pretty sure I introduced that to I was one of the first guys, if not the first person in Thailand to apply that in the real world. Use graph analytics for my central banking analysis of interbank connectivities. So that was way before Facebook. Okay, so this was about, instead of focusing on individual bank as an entities or system of bank as a composite or aggregate of a bunch of banks, I look at interconnectivity between banks through interbank lending channel, and I apply what's called centrality measure to see which one is exerting a lot of leverage in the banking system. So that was done for 2000, mid 2000, 2006, 2007, 2008, I think. Okay, so that was something that very early, but now you can get neural network that not only learn picture, like work with picture, like convolutional neural network, generate picture like DALL-E, work with text or generate text like chatbot. You can actually have neural network that learns about relationship between things. Okay, so it can learn to say that A is a friend of B, B is a friend of C. What's the probability that this guy is also a friend, or if this guy was introduced to this, they'll make good friends, something like that. Okay, based on connectivity. So this is general areas called geometric deep learning. And then finally, there's this thing that is a very may not make much sense to you right now, or may not mean anything to you right now. It's called learning chaotic dynamic system. Basically, in life, in any kind of analytics, there are two systems right now. Deterministic, y is equal to ax plus b. That's deterministic. You know a, you know x, you know the coefficient. You multiply, you take whatever function, you get y. That's deterministic. Then you have the random element. Okay, that's kind of random. So you can't do anything with it. You just sort of like put an umbrella around it and say this is the level of randomness we can't get to. Well, there are certain things where this apparent randomness is not random, except you just don't know enough about how things work to predict precisely. So randomness is not true randomness, it's a measure of ignorance. So how do you get system like a neural network to learn behavior at that level? That's not doable. Okay, that's kind of like a chaos. That's what's called chaos. Chaos is the middle ground between determinism and randomness. It's tricky because it is deterministic, but you can't predict it. So it looks random. But deep down it's not random. And you try to get as much as possible to the underlying mechanism. That's called chaos. Cryptography, again, blockchain, and we will talk about this cryptocurrency, smart contract, and all that. So this would be like topics that you can look at. Okay, look at those topics. Okay, now let's talk about lifelong learning. I could have started with lifelong learning, go to the emerging technology, but why do we learn? Why do we have this class called lifelong learning? Why don't we just have a class called what are the hot topics in emerging technologies right now, something like that, okay? Or emerging technologies 2024, and I just mentioned these other topics. Because change is a nature of things, that's why, okay? So it's about learning how to become lifelong learners, so when the world evolves, you can evolve with it. Change is a nature of thing, and the stock of knowledge, okay, that will get you through. In other words, the stock of knowledge is what you can accumulate right now. It's like food when you're going hiking or water. It's something that's supposed to last you a long time. Now, if I pack with you the knowledge of how certain machine works, when new kind of machine comes in, you're not going to be able to do that, right? But if I pack you with the knowledge with how do you guess how machine work by looking at the behavior, or how do you experiment so you can test input-output response of something that you don't know about, then when something else comes in, you can play with that, right? So it's about stock of knowledge that will get you through. So the stock of knowledge itself should not be outdated. The technology that we're talking about, Excel, can be surpassed. But the idea of programming, the idea of storing information, accessing, manipulating, generating report. This is something that's kind of like something that could, even though it's not gonna, maybe in the future Excel will not be two-dimensional, will be three-dimensional. I don't know. Okay, but you're still gonna have that perspective. And because change is the result of your action. Now, unfortunately, my generation creates a lot of problems. Okay, because we create a lot of advance. We create a lot of advance. And advance and discovery is a messy process. It's a messy process. So I generate a lot of junk. When you make prototype, you make a lot of junk. When you dig for gold, you create a lot of pile of dirt that's not usable for agriculture. Okay? My generation is the generation of pushing ahead, regardless of what consequence. Okay? Which is okay in the beginning. But when you get to the certain level, okay, when you get to the certain level where the trash you throw out start to come back at you, that's when it gets to your generation. Okay, so your generation has to be a little more clever. So your lifelong learning may not be about new technology, it's just going to be about discovery. It may be about technology, about managing the collection of existing technology and collection of waste. You can think of it this way, like my generation create tools, create things, new things, okay? New building, trash. Your generation is not, will not be tasked with just creating new things and more trash, but maybe creating new things and cleaning up old trash or converting old trash into new things, okay? So it's a different kind of challenge, and this is something that, in a sense, it's lifelong because frankly speaking, my generation hasn't come up with enough solution on this side. So the solution on this side is going to be emerging technology. Okay? And this is what I mean by the nexus of opportunity and challenges. So any kind of global, you have challenges, sustainable development, right? You know about 17 sustainable development goal. And we have, I'll talk about this later, sufficiency economy is a solution, waste pollution, right? Waste management right now is a problem, maybe you have to solve it with circular economy, climate change, global warming is a problem, okay? Well, certainly renewable energy is a solution, but so is carbon sequestration. Power and energy, you got a runaway necessity, you have energy driving everything is run by energy. So we're talking about renewable energy, okay? So these are the global challenges. Now, here's the thing. You can look at all this, okay, as a one-to-one. Here's a problem, here's a solution, here's a problem, here's a solution, here's a problem, here's a solution, here's a problem, solution. But I maintain that in your generation, there's gonna be a new kind of paradigm, new kind of industry, okay? Now, this is pure speculation. You don't have to be tested on this. You know how in the beginning, okay, go back 300 years, people were just learning to trade, okay? Was there a profession called trade regulation? There isn't, right? You just have people who sell, people who buy. The job of regulating behavior of the market, make sure that the market is scrupulous, there's a standard of consumer protection, all that. That thing didn't exist, right? That thing didn't exist, okay? Now, you would say if people were honest, right, you don't need that. But people were not always honest, so sometimes they sell you a pound of carrots, but it's not really a pound of carrots. So maybe there has to be a regulation mechanism for making sure that a pound of carrot is really a pound of carrots in a market. So that's market regulation, right? That became a job. Regulation became a job. Government became a job. All this didn't come before, right? So regulation becomes like a big job. Think of it, there's like millions of people all over the world. Tomorrow I'm going to work, go to a small medium enterprise promotion, and I worked in the past with organization that deal with security exchange and all that, right? So that's about regulating. So that's a new job. My guess is in the future, there's going to be a new job. And that new job is not producing, it's not regulating, but literally cleaning. Cleaning everything. Cleaning waste, cleaning radioactivity, cleaning deforestation, basically rehabilitate the environment. Now, you're going to say, how is this going to be financed? Same thing. Who's going to pay for somebody who makes sure that the carrot, a pound of carrot is worth a pound of carrot? After all, it doesn't generate anything, right? But there's a mechanism where if you are going to be in this market, you have to pay for, let's say, a listing fee, which will pay for the regulator, which will regulate the scale, let's say, of the market. Likewise, in the future, it's not just production, the cleaning up of the whatever waste, the current waste, existing waste, my generation waste, I think this is going to be something that literally itself will be a workload. And there'll be a mechanism to pay for this. So whereas right now, if you think about cleaning up trash, okay, it's an afterthought. It's what you do when you produce trash. In the future, trash cleaning up may be a job. Okay, a job, a well-paying industry that focus on, so you can imagine right now there's a mining of gold. Fine, there's mining of gold, right? Right now, who mines gold from electronic waste? There's like a town in Africa or something where people burn stuff and get gold. Okay, imagine that on an industrial scale. You can have a very modern, efficient corporate company that literally mines gold from trash. Right? So I think there's going to be like emerging tech industry, not emerging technology now, but emerging industry, where your job will be to clean up stuff. Okay, and there'll be maybe emerging paradigm where your job is not to make profit, but maybe social. I don't know. I really don't know. Okay, this is something that I write this down as my futurist view. I really believe that. I really believe that. At some point, we focus on production and consumption. Then we go to regulation and governance. In the future, it's going to be about rehabilitation. And I think that will be, if not your generation, maybe your children. And so when you learn, okay, now this is where I have a role to play in terms of what I bring to this class, is that we can do two things. Both of these are very good. Perspective is to look at, you talk about emerging technologies. If you're going to study emerging technologies now, you can look at history of technologies emerging, right? If you're going to look at history, that's fine. And there's actually, a full course in history of science and history of technology. You can take, Ph.D. program in that actually. But what I might do instead is, instead of focusing on history of technology emerging, I would actually go and pick lessons from history when things didn't go so well. So this will be like lesson from technological impact, unintended technological impact on society. So I'll try to bring some of this to class. Now, finally, what can you expect in terms of tools? Okay. Now, when I say tools, these are the tools that I think you can start playing with in class. But let's say you graduated from Basai. These will still be the tools that you can use. Okay. I group them in three things. It's not necessary. Okay, so the first one I have is Wolfram Mathematica, and this is the program you're going to have. The reason it does is because A, it's a computer program, so you know that it can do algorithm. But B, it's also an analytical engine, which means a certain concept which is not solvable. Let's say integration equation, you can't solve it in Python. You can try it with Mathematica. Now, there are rare occasions when you will actually need to solve analytical relationship. But just so you know, it's there. It's powerful. Okay? And so there's an analytical engine. This is something that you can't do with Python. You can do numerical integration. You can do analytical calculus. Okay? So let's say you study genomics, or you study spread of disease, epidemiology, right? There's a partial differential equation that tells you how fast COVID is going to spread given certain rate of transmission, right? Solving that PDE analytically, you would need analytical engine. And Mathematica is one of the most, there are other analytical engines that you probably won't know about it, okay? Second, it's also one of the most powerful probability and statistical analysis. You can actually throw in a data and ask it to find a distribution that fits. Okay, again, that's something you cannot do with a general language like Python. Okay, you can ask Python to draw a distribution, generate random variant to it, but to make this kind of inference, this kind of extraction of what the distribution should look like, that wouldn't be able to do. And we have interactive visualization, and we have so these are tools that I want to equip you with. As an example, I will show you that when I get into things like cryptography, I then use Mathematica to implement cryptographic functions. Okay, you know, blockchain is based on all this thing, right? Well, to learn how it works, I would code it in analytical program like Mathematica to say, okay, this is how it defines a Diffie-Hellman key exchange or something like that. Okay, and so I've done it. You don't have to do it. I'll show you how I use Mathematica to learn about the new technology that, you know, would be very difficult to understand otherwise. Okay. Now, second thing is online learning platform. And this is, I place a lot more emphasis on this, but it's a little bit hard to define. Because first of all, the most important thing that I use myself is YouTube. Okay? There are silly YouTubes, there are even wrong YouTubes. Okay? But there's a lot of right YouTubes. Okay? So YouTube is a huge, I've actually learned mathematics from YouTube. I've actually learned new mathematics from YouTube. I have relearned the mathematics that I already thought I learned, but from a different perspective. So, you know, when I was your age, I would learn things like Fourier transform, okay, from one perspective. YouTube would give me a entirely different construction for Fourier transform that I didn't know when I was in your age, okay? So it's not like a new thing, it's an old thing, but it actually gave a new perspective. I get a lot of stuff. I get my YouTube is very important, but you have to get to the right YouTube. You can't go to the silly ones. Okay. The other one, now I want you to think about personally investing your own money, because mathematics is already expensive. So I asked Tamara to buy 100 license for Basai students. That's a lot of money already. So I'm not going to ask for any more money, but you can. I think Brilliant is a very good one. Brilliant.org. Okay, it's not that expensive. Okay, compared to whatever else you pay for Starbucks or something, you know, that is nothing. But I certainly can't ask for the university to buy your subscription. Okay, Brilliant.org is even better than YouTube. It's just not as diverse. It just doesn't cover as many topics. But for getting you from A plus B equal to C all the way to tensor transform, Brilliant is best because it actually is a step. It's a step. YouTube is not a step. I know it's a step because I've already, I'm here. I can say, okay, this YouTube fit is this step. This YouTube is for that step. This YouTube for that step. But for you guys, you just see a whole bunch of YouTubes, right? Okay, so it's not. It's a little bit hard to have a kind of learning program. Brilliant is not. Brilliant is designed literally from the ground up. So it's step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So you almost guarantee that you can understand step 8 if you went to step 7. Okay, with YouTube, you're not. So consider maybe, and let me know if you're willing to do that, because there's some project, some technology you can learn in there. Like I said, I talk about quantum computing as a good example a lot. It's in there. Genomics, I'm not quite sure. I think it's in there as well. Okay. Now, finally, things like ChatGPT. This is also something that I think is worth your money. I don't mean ChatGPT that's free. I mean the one where you have to pay, because when you pay, you can get plugin. Now, the plugin, one of the most powerful plugin right now is Wolfram Alpha, which I think is worth, that alone is worth subscription to ChatGPT. However, because Wolfram Alpha is actually the same engine as Wolfram Mathematica, it's kind of like has the same kernel in the back. So you don't have to go to ChatGPT to go to use Wolfram Alpha. Okay, you can just go to Mathematica, which you have. You will have. Okay, but let's say you graduate from here, and you don't want to buy Mathematica, which is expensive. You can buy ChatGPT plugin and access Wolfram Alpha. Okay, you won't have other things. You won't have other things. You have indirect access to it. It's like instead of asking Mathematica to do something for you, you have to prompt ChatGPT to look for answer that would require you to do this. It's doable. It's a bit painful right now, yeah, because it's not direct and it's not guaranteed. ChatGPT is not a compiler. Okay, so it's not always correct. But with this, you can plug into. What happened is this: ChatGPT is very good at synthesizing knowledge, but the knowledge it feeds on is just internet. Okay, so you can't really ask internet to take a factorial of 749 because internet hasn't done factorial of 749. Okay, however, ChatGPT is smart enough in this case to know that factorial is a gamma function. You can use approximation of gamma function, and it maybe go to Wolfram Alpha and ask it. Okay, so what happened is for a lot of calculation that requires genuine calculation, you would not ask ChatGPT. You would ask ChatGPT to use Wolfram Alpha to do the calculation. In which case, then that will become reliable. Okay, but if you just ask it to do something like calculate the trajectory to go to Mars or something, it gives you something silly. But if you ask it for something like solar mass, certainly that's easy because that's common knowledge, right? It's in the Wikipedia. So you can think of ChatGPT as very good at the way I would use it. Even though ChatGPT is generative and it's very tempting to ask it to generate things for you, you should use it as a very, very clever Google prompt. Because when you do Google prompt, it does this kind of page rank thing, and the relevance is based on numerical popularity criteria. Whereas this is based on more semantics. So the Googling result that you get will be more in line with what you want than a Google prompt. Okay, because Google lines by the numerical graph theoretic thing that I told you about earlier, but it doesn't align things by semantics. ChatGPT tried to do it by semantics because it predicts likelihood of the next word or the response. So it's going to be more precise to your liking. Now, even before ChatGPT, when I was Googling Google search, I always Google in sentence. So I don't just say topic, I say, how bad is this? Because I try to sort of like flesh out relationship between words in the Google, which Google tried to do somewhat successfully, but with ChatGPT, it's even better. So instead of saying, what's the trajectory to Mars, say, what information will I need to calculate satellite trajectory to Mars? There you will go. circular orbit of Mars, planetary equation, all kind of stuff, escape velocity, and then we try to synthesize it for you. Another thing I do a lot, and in fact I do it almost every day now, is instead of doing literature survey with Google, I do literature survey with ChatGPT. In which case, it will come with PDF reader. There's a lot of plugins. But what it does is it would actually go and read PDF and fish out content that's close to what I need. Okay. So when I do survey, I get links. Okay. And I just specify that give me links. I tell ChatGPT. I don't say, give me something. Give me links to actual paper on this subject. Okay. And then I click the follow link, and sometimes it's not valid, obviously. You know about silly links that ChatGPT came up with, right? But anyway, it's easy to verify, just click it. And sometimes it takes you to the, so it's not guaranteed to be correct. But if it is correct, it's more likely to be in line with what you want that Google says. That's what I'm saying. Okay? So it's to your taste, it personalizes better. That's what it is. Okay? Yeah. Factually, it's inferior to Google because Google, based on the page, is factual. Okay? So you rely on the fact of the page. But it doesn't synthesize anything else, so there's no extra source of error. So in that sense, Google is better than ChatGPT because it relies on source. It doesn't synthesize new information. But Google is not as personalized. Right? So, and I use mind map, when I ask it to summarize, they summarize and then draw a mind map. And I do that a lot. Now, I use mind map on my own, not from this, to create concept. Obviously, I do this, right? But when you try to find out about new things, how, for example, let's say biodegradable plastics, okay? So you say, how does biodegradability of plastic relate to strength of plastic? Okay, this will be something that requires connection. Okay, so if you do Google search, you will do something like plastic strength or degradability. Okay, but with this, maybe once you found out this article on strength, you can say, oh, here's a mind map. Mind map say biodegradability is inversely related to strength. Could be, I don't know. Okay, so the stronger it is, or more elastic it is the less biodegradable. I don't know. I haven't done it, but that's the sort of thing where it can help you draw the mind map. Now, once you get the mind map, obviously you would customize it to your life. Now, first time I've gotten it. Okay, so here, what I want to do is give you this. This is an example of what I did earlier for you, for this class, actually. Okay. So, again, now, by the way, do think about it, okay? If you're willing to pay for the ChatGPT plugin, it's only a few $100 a month, I think, right? Same with brilliant.org. If you can, your project is going to be even more interesting. But even relying on just Mathematica, okay, Mathematica has Wolfram Alpha inside already, so you don't have to pay. Anyway, so here, this is a paper that I'm going to send you the link to. Okay, just go download. Basically, this introduced the concept of what you do is you ingest the material from YouTube. From the YouTube, you use it to probe different topics, okay? And then you survey, then you measure. So this is what I call ingest, probe, survey, and imagine. So this is a method that I kind of came up with for this class. If you want to learn something using YouTube, not just as a infomercial or entertainment, but literally use it as a starting point to get into biotechnology, to get into quantum computing. This is what you do with it. Okay, roughly speaking, I'll send you the paper. You read the paper, obviously. But the idea that you start with is you ingest what is in the content. But you don't just ingest by listening. You ingest by creating a mind map of the narration. What do I mean by mind map of narration? When I have a new sentence, I have a new note. If the new note say A is equal to B and C, then it branches to B, it branches to C. Or if this is true, then something is true. Or because of this, so the logical, so in other words, you can think of the entire narration, like information, documentary, YouTube, and the example is here. Okay, I'll show you. So this is actually a real YouTube video. It's still up there. I think it's this one. Okay. This is a long narration, 10 minutes long. Take that narration, not word for word, take it and make it into a mind map so that you have heading 1, heading 2, heading 3. Heading 1 branch into condition A, condition 2 has causality C. Okay, so you break, you take what this lady is saying, okay, you take what this lady is saying, and you turn it into a mind map. Okay, that's the ingest part. Okay. The pro part is to say, because each point, they can't go through the whole thing. So they'll say problem, solution, but then there's still problem. And there'll be a hanging point. At some point, the branch is going to terminate because the video can't answer everything. So it could end up with a sentence like, all this depends on the ability to synthesize this molecule at high temperature. That's it. Terminates there. So that becomes an endpoint. And they go to something else. Now, and there'll be a whole bunch of this endpoint. Probe means you decide which end you want to investigate. So for you, this problem gets outlined into so many cause and conditionality. And it gets to this point, this ability to synthesize this molecule at high temperature, at room temperature, say, becomes your thing. That's your probe. That's your jump off point. You're going to probe to this. That's when this thing backtrack become the whole subject. Okay? Now, you're not going to do this. You might do this for one, maybe there's one jump off point for this video. Maybe there are 2 jump off points. The point is that if you just absorb the whole video, then you're at the surface level. You never dig deep. To dig deep, you definitely have to go to the dead end. When they leave you hanging. This depends on whether or not India has opened the right for mining of these rare minerals. Endpoint. That becomes a jump off, something like that. Okay. So there's a lot of material and scientific dead end, not dead end, but you know what I mean. The terminal point. You probe on those. Then you go to survey. Now, when I wrote this paper, I didn't rely on ChatGPT to be traditional search, Google search. But if you use GPT, you can do that. So, are there people working on synthesizing this molecule at high temperature? Can you give me link to labs and white paper or working paper on this topic? Okay, so this is where ChatGPT comes really helpful. Okay, but you don't have ChatGPT, you use Google. So this is where you do survey around it. Okay, so all the touch point becomes a probe point, becomes this thing blows up, but it doesn't blow back up to biodegradable material. It blows up to whatever it is around a certain area, molecular synthesis, whatever. And then you start to, and the last one I leave out called imagine. This is the bit where you imagine that you're going to play. Remember, one of the definitions I told you earlier about emerging technology is that not only minority of humanity working on it, there are many roles. The imagination refers to that point. In other words, you want to get in the game What part of that game? Okay, and this is very important for Basai students because you really have to find where you belong. You're not like other students, In Chulalongkorn, if you're an engineer, you graduate as an engineer, you know where you belong. Okay, you study medicine, you know where you belong, or where you can walk in and make it your job. Basai, there isn't a template or tailor-made job description. Maybe consultant, maybe, but not really. So you have to define what you want to play with. What's your role in it? Your role is to invest in a lab that synthesizes molecules at high temperature. Your job is to actually go into research, get a master in biochemistry, and actually work on this. Fine. Okay. So where is your part in this? Where is your part in this? Or what else you want to learn about it? And so I'm gonna send you a link, and that's your homework. Your homework is to do two things. First, watch the video. Just watch it. Okay. And then look in the paper of the mind map that I create for that video. Okay, and follow through this process. Does that make sense? Does that make sense? Okay, so how come there's only half of you left? You take attendance. Okay, so they'll take beginning attendance and end attendance. But anyway, so your TA is going to create a line group. I'll send the link, right? You go to the paper to download, and again, you can do it whatever you like, but what I would suggest is just try to watch it as if you're watching a video. And now watch it with the map. Okay? And with the map, there's some jumping point. Okay? Now, if this were your thing, you will be the one who decide which pro point you want to get into. And once you go to that pro point, you can do survey, you can, so forth. Okay? So it's kind of like it's my method for getting you to learn something substantial rather than just being informed. Right? And now, obviously, this is an example. Not all of you is going to go into biodegradable plastics, right? Yeah. So now, as an assignment, so this is assignment number 1. Okay. Assignment number 2 is pick your own video. Now again, there isn't just one video for biodegradable plastic, right? So I'm just saying this video is good enough as a starting point. When you go survey, you're not just reading technical paper, you're also watching on the YouTube as well, right? But what I would like to do, by the way, for this class is when you do the survey, you don't just read other blogs and watch YouTube, you actually read technical papers. Okay, so in this case, there could be a technical paper about biodegradability of certain things. And you will read it and you will understand 30% of the paper. Now, let me say that again, guys. When you read scientific academic paper, if you can understand 30% of the paper, you get your money's worth. Most people don't read academic paper because they don't think they understand. Because they think by understanding, they literally understand the whole thing, like you read a novel, right? When you read a novel, you know exactly what happened. When you read a scientific paper, there are some details in the implementation, in the algorithm, in the this, in the that adds up to about 70% that you will not be able to understand at first reading. If you can read a scientific paper and understand 20-30% at first reading, it's good. It's good. And this is not exception. I'm not just I'm not, talking down on you because, you're new. When I read new paper, same thing, 30% I'm good. Okay? Except, of course, as a professional, if this is something that once I read the 30% and I think it's something completely relevant to my work, then I keep rereading it. Okay, so I get more than 30%. But if you read the first paper, any scientific paper, no matter how messy looking, don't be discouraged just because you only understand 10 or 20%. That's fine. Yeah, let's make it 20%. Let's make it rule of thumb. Read any scientific paper. If you understand 20%, good. Good. What I mean by good, it's good enough for you to know to make decisions. And that decision is, for my decision, it's usually this. For my decision, because I have a problem to solve, I kind of know this is a basket of technology I need. So this is, these are the sort of tools I need. I try this. If this is a good model. So if I say 20% is good, what I mean is that I can tell myself whether or not for this project, this model is relevant. Or I can say something like this. This model is almost perfect for the problem I have. Unfortunately, the calculation used too much computer. So it's a dead end. So I can make all the decisions. Okay? That decision doesn't mean rejection, not because it's irrelevant. Oh, this is perfect. This is perfect. A lot of times, this is what happens. I find in a scientific paper, let me tell you this. A scientific paper is like a cooked dish. It's a combination of ingredients and way you cook it. Okay? Sometimes, this is what I tend to find. The way it's cooking, the way it's done, the methodology is perfect, but the data is not compatible with my data. Okay? I do that, I find this all the time. And you will find, and think of economics. Let's say you have a friend in economics, department of economics, right? And one of your friends is in America, in the United States, where the Department of Statistics gathers statistics on everything. So they build this huge general equilibrium model. Okay? And they say, oh, this is the model I use. Okay? And then you say, oh, that looks good. I want to use it for, let's say, in Thailand. Thailand may have good statistics on fishery and rice farming, but it may have nothing on retirement benefit. Okay, you see what I mean? So the methodology doesn't match. Now, when I say good, it means I read this paper and I say, does it match? Can I use this? Can I copy this homework? I can't copy this homework because this thing relies on 10 variables, 5 of which are not available for my problem. Okay? Or this paper is good because it points to the source of data I need, but this paper did a linear regression, which is a silly thing. I'm just going to throw it away. I'm not going to follow that linear regression. I'm just going to read that data preparation part. Because I read the whole thing, but I'm just going to use the data part. Or I read the whole thing, I'm just going to use the methodology part because the data is not compatible. Okay? So yeah, a rule of thumb is good means you understand 20%. 20% tells you whether or not in the final project you should have this as a reference. Okay? Either because it has relevant methodology, application, data, or way of thinking, or explanation. Okay, so you will have think of a typical. Let's say my project when I do for my clients. Okay, I will try this. Say I'm doing analytics about client engagement. I would find 50 papers. Okay, maybe there are about 5 of them. Then I would say this one is good for the relevance. This one is good for this. This one. I'll give you a good example. I did fraud detection for the Department of Revenue Department. Okay, so what you can do is you have companies that sort of like have a supply chain, and this one gets high rate, this one is low rate. So what they do is they make this one profitable and this one lose money. But actually, it's just adjustment of accounting. Okay, so how do you detect this? So I researched, maybe I came up with 20, 30 paper, a lot of them from China, because they do a lot of tax evasion there. And I find one paper that's very good for for the interactive visualization, another paper that's good for the database, you know, and in the end, came out only about 3 papers that's really relevant. Okay, but I could do this because the 20 paper that I came up with, I could understand at least 20% of each, let's say something like that. Yeah, I'm just giving you a rough number. Okay, so that's what I mean by survey. Okay, once you get to something that's really relevant, you dig deep, then it's not 20%. Okay, then it's not about 20%. Then it's about 80% of the paper. It's about download. And nowadays, your life is much better. When I was your age, academic results are printed on paper. Nowadays, academic result gives links to the data set and the algorithm used to run the data set. So that case, when I said the methodology is good, but the data is not relevant, you know what I do? I download the function, Python code or whatever, but I don't use a data set, I use another data set. Right? It's so much, life is much better. Okay, now that's beyond survey, right? Because you're actually replicating the result. Okay, you would do that. You would do that. So this ingesting the topic, you know, find the point you want to probe, survey the area, imagine what you want to do. This is how best to get the information content from the YouTube. This is not the end, right? Once you latch onto those, you get, oh, you got key paper here, key paper here, key paper here, key paper there, and I want to, then you go deep, then you dig deep. Okay, so this is just to make a very thick, substantiated way of getting oriented. Because after all, these are explainable. These are explaining a document. They try to make you understand what are the issues. You go in and deconstruct their narrative into logical progression. Because of this, and this, but not that, because of that, if then and else or, and then decide which way you want to go. Okay, so it's like it sounds a little tedious, right? Instead of just enjoying 10 minutes of watching, you have to say, okay, this person started a new point now. This point actually goes back against that point now, so I have to draw an arrow back. You know that thing. So download Xmind to do this. Okay, download Xmind to do this. Now, presumably in the future, ChatGPT 7 will watch this video and draw the mind map for you. Maybe you're doing that already, okay? But I want you to do it yourself. So that would be, so you have homework, read this, blah, 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 and then come up with a video and a mind map. Okay, doesn't have to be that extensive. Okay, this is your first try. This is all about, this is the learning by doing part that we talk about by side. You pick a video, your subject, take the mind map, highlight the bit you want to go into, expand the bit into literature. Just give something like 5. Okay, so I want to go into synthesis of molecule at high temperature. And these are 5 research papers. And then again, if you get 20% of each, fine. Come tell us about it. So it's going to be something like this. So it's going to be this class, I hope. It's a bit tricky to do it with, you know, a lot of people, but it should be like a self-learning lab with me supervising. Does that make sense? Okay, so a lot of I'll give you a little bit less some content to start with, like how quantum computing works and all that stuff, but mainly it's about you. Okay, and so think about this, and also think about the subject you want to work with, and we have to think about whether or not it's going to be like individual group project. But, okay, maybe you guys can take the vote. Maybe if you have maybe we can have like a cluster, not a group. Maybe this is the this is the microbiology cluster. This is the cryptography cluster, something like that. Okay, and then everybody have individual paper, but they work in a cluster. You can do that. It's up to you, really. Just make the best of it. Okay, I'm game, and and I'm flexible enough to go with the flow, as it were. Okay, okay, good. Boy, on the dot. Hey. So I'll see you guys next week.